Oh, right. Hello, everybody. How are we all doing? All good? Right. So it looks like everybody's muted. So just double checking that we're all prepared ahead of this workshop, which is good. So just to double check. Oh, right. Hello, everybody. How are we all doing? Seconds to sort out what's going on here, which was our YouTube stream just going a little bit mad there. So please forgive me for that. Right, okay then. So people are just gradually coming into the chat. Guys, can you just give me a thumbs up just to make sure that you can hear me all loud and clear, which is great. I'm seeing you guys across the screen. Brilliant, fantastic. Thank you very much. So I just want to say for tonight, guys, thank you so much for making the effort to come today. It does mean a lot. So it's also lovely to see as many of you on the screen as possible, which is great. So as per usual, what I'll do then is I will wait for the next couple of minutes just to let anyone who may want to join the chat come in as well, which is the case for a couple now, which is great. So otherwise, I hope all of you have been doing well since we last met up. It hasn't been, unfortunately, the best for astronomy, I have to admit, really, for the past month or so. So, you know, it's been a bit tricky, although tonight's looking great, though. So if you want to have your chances of doing some astronomy tonight, tonight's the chance. We've got some clear skies. I understand this may not be true for everybody who is tuned in onto the chat. I'm just saying that for the weather forecast for the southwest of England, which is looking good. So I hope that's the same for you guys as well. So as you guys are thoroughly aware, tonight we will be discussing celestial events. So this is a workshop I have tailored mainly towards solar eclipses and lunar eclipses, for example. I've decided to make quite a rash move, and I'm not going to discuss meteor showers tonight, only because in August we're going to have a fantastic meteor shower, which I won't spoil for those of you who aren't aware, but I will cover more about meteor showers in August because I felt it's more fitting with some of the events which will be taking place in August. And there's another reason why I'll be covering solar eclipses, but we'll get on to that in just a minute. So I'll just give everybody a chance just in case. So now's a good time, guys. If you haven't got a drink, make sure to go and grab one. If you want a little snack or something to eat whilst we're going through the chat, that's another good reason to get yourselves ready. Otherwise, if you're prepped and ready to go, that is great. And without fail, I will get ready very soon. So just giving a couple of moments. Lovely to see so many of you enter the chat as well into the Zoom call. So again, for new people who've entered into the call, just to say thank you very much for joining me this evening with our next virtual astronomy workshop, which we'll be talking about celestial events. So, you know what? We're reaching nearly 4 minutes past 7. We've got an evening to enjoy, and so I think we just crack on with it, guys, all right? So I think we'll get tonight ready, and if anybody joins in, I will add them. So let's crack on. Just get this sorted out a minute. So please bear with me with some very minor technicalities. Right, okay, let's do share screen. Fantastic. Right, here we go. And we'll go into tonight's presentation. Just wait for this one to load as well. Okay, so it's just taking its time to think about it. Right, here we go. Let's get you guys to top the screen so I can see all your lovely faces. So for anybody new who has joined, I'd just like to say thank you very much for showing a great interest in joining Space4All. So Space4All is an astronomy organisation that I've set up, Josh Jory, to teach the basics of practical astronomy and to engage members from all backgrounds as well. So tonight we're going to be looking at celestial events in our virtual astronomy workshop during these weird, unprecedented times, which is the lockdown. So without further ado, let's carry on. I always like just to mention a brief series of instructions. So I know you guys have done that already and I appreciate it. So thank you very much. But just to run through them, just in case, if I could please ask everybody to mute themselves before we begin the workshop, just so that it's fair for everybody and gives chance for members to listen in on the talk itself. If you guys have any questions whatsoever, however long or sophisticated they may be, simple questions as well, please make sure to use the chat tool, which is available in the Zoom tool below, and just begin that with questions so I can highlight those at the very end, please. And otherwise, if you guys have got any questions at all, please don't hesitate to use the raise your hand tool. So I can use this to see that you guys in the top screen there would like to ask a question, and I can do my best to answer that as well. All right. Otherwise, I believe we are ready to go. For those of you who aren't aware then, I've mentioned really what Space4All is about, but teaching the basics of practical astronomy and stargazing, and I link teaching the basics of astronomy with raising public awareness and becoming increasingly more aware as to how astronomy is being impacted through the likes of, say, light pollution, mega satellite constellation, and I believe more of us who are interested in astronomy will feel compelled to protect it. This is the reason why Space4All is here. And as I've mentioned, virtual connections, the digital age allows us to connect in a way which we've never been able to do so before, and so keeps us connected through these uncertain times, ... So, celestial events. I have categorized them tonight as eclipses and transits. What are these unusual, amazing events? Well, you're going to find out tonight. So first of all, I'm going to cover one of my most passionate areas, which is solar eclipses. Solar eclipses are a very dramatic celestial event. So this takes place when there is an alignment within the solar system. And this occurs between the sun, which is our central star, in the center of our solar system, and this interacts with the moon, to which we then observe it from Earth. So it's a simple alignment between the sun, the moon, and the Earth. And this allows us to observe different types of eclipses. And what is so important, and I must stress this and must reiterate it, solar eclipses can be dangerous to observe. The reason why is because, as you guys are aware, when you look up to the sun, it can dazzle your eyesight. So if you are in the attempt of observing a solar eclipse, please use safety glasses, whether that's in the form of solar eclipse glasses or simply by using a solar filter. And what this allows us to do is to block in the region of 99.99% light. I know, a bit techie, but it has to be said. And this allows us to observe a very small spectrum of light through a filter. And in doing so, this makes it safe for our eyes to safely observe events like the eclipse, for example, or the sun itself. And we can also observe some of the solar features as well, which we'll have covered in a virtual workshop coming up, which discusses what we can see on the sun. So without further ado, let's have a chat about the different types of eclipses, or solar eclipses rather, that we may be able to see. These are, in my opinion, as an astronomer, the most dramatic celestial events of their kind. Total solar eclipses are the occurrence whereby in the moon's elliptical orbit around the Earth, which is like an egg shape, just imagine it, a hard-boiled egg, that kind of shape, and it just happens to be at the right point during this elliptical orbit, the moon and the sun are the same apparent size. So when a total solar eclipse occurs, we get a perfect alignment between both celestial bodies. And inevitably, this means that we can observe total solar eclipses from a very specific geography from around the world. The last total solar eclipse which occurred was back in December of 2020, which was visible from Chile in South America, where it crossed a very brief region of landmass from west to east coast of South America, especially notably in Chile and Argentina. The point I'm trying to mention here is where light has been traveling through space, and particularly with the eclipsing bodies, which are the sun and the moon in this instance, a very small channel of light or shadow, the moon's shadow, actually reaches our planet on Earth. And for those who happen to be lucky enough to be in the moon's shadow at that moment in time, will see a view similar to this, a highly dramatic, highly sophisticated celestial event that is a total solar eclipse. I've been fortunate as an astronomer to observe one of these, which happened in 2017, which was also known as the Great American Eclipse. So this is when the moon's shadow crossed from west to east coast of the United States, and I was able to observe this event from Nashville, Tennessee. Now, the thing is, these eclipses are weird. I think there's no other way of describing it, only because, we begin to see what are like these typical partial phases as the moon slowly drifts across the solar disk. But then gradually things begin to take a very dramatic turn, only because in those 10 minutes leading up to totality, the light changes. And all of a sudden, we begin to see almost like a sunset array around you. You notice a drop in the temperature. You begin to see and hear nocturnal wildlife and insects coming to life. And then suddenly, in the moments leading up to totality, you look up to the phenomenon happening above your head, and then suddenly you see an outburst of the diamond ring, as it's known. And this is the final beam of light which is visible as it is eclipsed between the lunar craters on the lunar surface. And all of a sudden, the moon's shadow sweeps across and you are obscured by totality. It is fantastic. So much so you can see some of the major constellations of the night sky, permitting on the time of year when the eclipse occurs. And it's even possible to observe naked eye planets such as, for example, Venus. You're able to see Jupiter, Saturn even, some of the brighter stars in major constellation. Notably, some astronomy friends have told me you can see the stars of Orion, you can see Canis Major, for example. So this gives some indication as to really how truly dark a total solar eclipse gets. They are fascinating because there are so many features, which I'll go on to discuss in just a second, which we can observe during a total solar eclipse. They can vary in length due to the nature of the elliptical orbits at that moment in time and their direct path across the surface of the Earth. And most of them, which was the case with 2017 anyway, occurred for about 2 minutes, 10 seconds. These eclipses do not last very long. However, there is one total solar eclipse occurring, I believe, in 2025, which will cross over Egypt and will last duration of 10 whole minutes. So if you're in the right place at the right time and you've got clear weather, wow, you are in for a treat, because the amount of details you can see with these celestial events and this phenomenon is staggering. This image captures what I was talking about, which is the diamond ring effect, because you see the eclipsed moon just beginning to take hold, and that final beam of light from the solar disk happens to shine through the craters of the moon, or rather the mountains, that would make more sense, and really shows such a dramatic theatre in the night sky. It's probably one of the most emotional experiences that I ever had as an astronomer. But also, after the moon is eventually eclipsed, we begin to see some very intriguing details here. These pink blobs that we see, or rather appear as blobs, are in fact prominences. This is a feature from the solar disk, which you can see, which is material and debris from the sun being spewed off into space. Some of these prominences being much larger than our own planet Earth in this instance. So if you consider that in terms of perspective, these prominences are humongous, and where this is the only chance really that we can safely observe prominences with our unaided eyes. What's also worth mentioning as well, and very similar to the diamond ring effect, is a group gathering of diamond rings, as they're called. But when you have a cluster of them, like in this image, which is demonstrated, They are known as Bailey's beads. It's where you begin to see a number of various light sources emanating through the lunar surface, and it is really spectacular, and it happens very quickly too. This image was recently shortlisted for Insight's Astronomy Photographer of the Year, and I love the dynamics of this image purely because it demonstrates what I'm talking about here in the very quick procession, which is Bailey's beads eventually merging into the final diamond ring before the solar eclipse takes place. And we can also observe the various stages of being able to observe solar prominences along the solar and lunar disk. So it's really great, you know, during this few moments of totality to observe these interesting features. It's also worth pointing out this diagram to you as well, because as I mentioned, I've been talking about prominences. They are gorgeous, but the chromosphere is another really interesting feature. So this is really the outer layer of the sun's atmosphere and appears almost as a pinkish tinge across the lunar disk when the moon is totally eclipsed by the sun. In this instance, it's really stunning to see. But also you have the inner and outer corona. It's really, this is the material that we can see being ejected off into space from the surface of the sun. And the thing what makes total solar eclipses so dynamic is that this is a feature that is constantly changing. So from one eclipse to another, we begin to see the shapes of the corona change. So as I've shown you in those previous images, if I can go back, no, I can't. So give me a second. Look at the difference between, say, this image and this image. Look how the corona changes. Then with this one, you begin to see some beautiful sweeping like motions within the corona, and you can also see some abruptions near towards the magnetic poles in this instance. But look at this one, it almost looks like a sunflower. And for those of you who were lucky enough to observe it, I believe this is a composite image from the eclipse which took place in 1999. I was only 2 years old then, and apparently stuffing my face with a packet of Maltesers. So unfortunately, I can't recollect that event. So apologies. So moving forward then, so I hope this has covered everything with relation to total solar eclipses. So what we'll do now is move on to our next type of eclipse, which is this kind of eclipse. This is a composite image of the total solar eclipse just for purposes, but also we have the Earth's moon's shadow, which we can see from the surface of the Earth. This image was taken from the International Space Station and just gives us some perspective as to what a total solar eclipse looks like as seen from the ISS. Annular solar eclipses. This is our next type of solar eclipse, and boy, these are some dramatic events. They're unusual in more ways than one, purely because technically, and this is quote technically, they are total solar eclipses, but there's a difference. There's a difference with annular solar eclipses, which is the elliptical orbit of, in this instance, the moon. The reason why is because the moon is more further away in its orbit when one of these eclipses takes place, which means that the moon appears smaller and does not totally obscure the sun. So we see some very dramatic views, this one being an iconic example where the moon is further away in its orbit, and we see similar to 100% coverage, we get what is called the ring of fire effect, which is what you can now see on your computer screens. This is when at maximum point of eclipse that the moon and the sun align to appear a ring of fire effect, which we can see in the night sky, or rather in the daylight sky, if that makes sense, but in terms of astronomical perspective, in the night sky. They're dramatic, and you know, you see images from various photographers from around the world, and they really are stunning to see, because it's only in those final moments, just like with a total solar eclipse, that we can really see how the dynamics of an annular eclipse works. I have to be honest, there haven't been too many coming up, but there is one coming, but which I will discuss in just a moment. But just in the series of images, they are truly stunning to see. They're highly dramatic, and I think it's fair to say they're quite unusual. So it's very rare chance that we get to see an annular eclipse of this stature. So this is just a nice close-up which demonstrates what I'm talking about here, the alignment between these two celestial bodies. It looks very interesting, we'll put it as, in this case anyway. Now, this is what I'd like to move on to, which is partial solar eclipses. Now, these I think are some beautiful events to be able to see, purely because you can see that slight interaction between both the sun and the moon. They're quite unusual, really, in a sense, because most eclipses anyway build up with a partial phase, as, say, in this instance, the moon travels across the solar disk. But this is when we begin to see the first interaction, really, of the moon beginning to eclipse the sun. And so when observed, whether that be at any point during an eclipse, it is a dramatic sight to behold. So let's go on and have a look at some examples. I just decided to select a series of images, really, because it covers really what we've already discussed. But these are just some fascinating images where photographers from around the world have been able to capture some truly stunning sights of the interaction between the sun and the moon. And from a photographic perspective as well, it's really interesting because we can get some really interesting compositions when, say, a solar eclipse takes place in the morning or the evening skies. But typically, when I've observed solar eclipses, they're quite well positioned enough in the higher up in the Earth's atmosphere, being able to see them, which is fantastic. Something else which I've just thought about as well, and I think this is a comment for the more avid astronomer, but you can also use another type of filter to observe solar eclipses. It's worth mentioning, and if you guys who are beginners want to learn more about this, I'm more than happy to tell you, but most solar filters are made through white filter spectrums. So we observe only a certain wavelength of light. However, there is one type of wavelength which is safely observable as well, which is known as hydrogen alpha. For me personally, as an astronomer, it's a particular wavelength which I think allows us to observe more detail. The reason is for hydrogen alpha light, it's skimming through various wavelengths of light and allows us to reveal much more structure on the solar disk and becomes more apparent as the moon begins to eclipse the sun, which allows us to see details like prominences, as I've already highlighted it earlier in this presentation, which means if you're lucky enough, you can get a sneak peek of the prominences before they may well be totally eclipsed. But we can also see surface features as well. We can see what is known as granulation, which is a very granulated like texture that we see on the solar disk. I will discuss this also in the solar workshop, which is due very soon, but you can see sunspots as well. So when observing a solar eclipse, it's worth noting that you'll be able to see some unusually dark patches on the solar disk. And this is where the solar atmosphere has cooled ever so slightly and creates abruptions on the solar surface. So it's just worth mentioning that as well for anybody who may be interested or if they wish to divulge further. But again, some really beautiful shots here, really conveying a true perspective of various eclipses which have been documented previously. I quite like this one, especially being photographed up against a series of boats out towards sea. I believe this was taken in looking towards the Pacific Ocean, actually. So it's just beautiful to see that dynamic really between the two celestial objects. They're gorgeous. Now, I couldn't help without putting in a couple of my own images. So this is one of the images that first got me into astrophotography, where my astrophotography journey began on March the 20th, 2015. So as I'm aware, you guys may well have observed it as well, but there was a very strong partial solar eclipse, which was visible in 2015. So we had a very good coverage up to around 75% coverage, which is visible visible in this central image, and was the first eclipse which I was able to observe at that time with an astronomy group based in Wiltshire. And so this was the results from the event itself. So as I've discussed earlier, this is the initial first point of contact where we begin to see the lunar disk touching the sun, and gradually this begins to creep across into a relatively strong partial phase until eventually we reach the point of greatest eclipse, which was around 75% coverage. And I do remember when observing this eclipse, it was like observing a smiling face in the sky. It was a very unusual celestial event, actually, looking back. Then gradually the lunar disk would begin to move away and gradually creep away ever more closer until the sun returned to somewhat normality. But again, all I can remember really from that solar eclipse is how dark it got, how cold it got as well. And yeah, it was a very eerie experience, but it's the fact they're so dramatic and so quick, I think, is why I like them. But I just had to fling this image in here as well. And then the image that I was able to capture from 2017 of the total solar eclipse from Nashville, Tennessee. Beautiful event, being able to share that with some of my family out in the United States. And honestly, it was all over the news. I couldn't believe what I was hearing. All the American television channels were going mad about this particular solar eclipse. You'd be driving along interstates, there'd be banners up saying solar eclipse, don't park on the road, and all these kind of things. It's like, wow, this thing is going to happen. So, you're just hoping and hoping and hoping that the weather is going to be clear. And with this particular eclipse, I seem to remember that it was clear from literally the moment the eclipse began, but in typical astronomy fashion, it begins to cloud over 10 minutes before totality, and teeth are gritting, and you're thinking, I'm not going to see this event. You've traveled all the way around the world and you're not going to see it. So you're just hoping that you get a break in the clouds, which luckily we did. And, an astronomer once told me, with regards to astronomy or celestial events, you must always have faith. And I've never forgotten his words either. So if you guys are going to observe an eclipse soon, which I hope you are, just remember, have faith, whatever the weather plays on the day of an eclipse. So much so, a very influential figure in the name of astronomy, Sir Patrick Moore, also mentioned that he was observing a total solar eclipse. I can't remember which year it was, but it was raining in about 5 minutes leading up to totality. And then suddenly, exactly the same story as mine, the heavens cleared and he was able to observe totality. So that just proves the point, really. Which brings me on to this very dramatic slide. June the 10th. What on earth is happening on June 10th? Da, da, da. This is happening. So this is what is going to be taking place as an annular solar eclipse. However, a part of that eclipse will only be visible from the United Kingdom. So this is a graphic which I was able to surf online, and this demonstrates what will be happening exactly on June the 10th. So just in case any of you guys haven't seen this before and are thinking, oh, this is mind-boggling, what is this map? Basically, this describes all of the key information that astronomers need to know if they're going to try and attempt observing this particular solar eclipse. Let me demonstrate to you. So these pink lines, which represent these rather large pinkish-like curves, represent when an eclipse will begin at sunrise. It is the opposite for the opposite curve, which you can see here, which is when the eclipse will be visible at sunset. The green lines which we're able to observe here indicate time, as you're probably already aware, which is measured in universal time. The red line, which we begin to see here, is the path of, in this instance, annularity. This can vary from one map to the next depending on the type of eclipse. So it means this could be the period, or rather the path of totality as another instance. But in this case, it's the path of annularity. So for viewers who will be lucky enough to observe this in regions towards northern Canada, the path of annularity will then eventually cross off over into Greenland and will be one of the first annular solar eclipse is to actually take place over the North Pole. So really, in that sense of a word, it's quite a dramatic event to behold. However, for those of us who are in the UK, we are within the perimeter of where we're able to see a part of the moon being eclipsed by the sun. So this is a good graphic which demonstrates exactly what's going to be happening when the moon obscures the solar disk. So I'll just play this out a couple of times, but as the time goes across, eventually, as you can see here, the moon shadow begins to interact on the surface of the Earth, and the UK will eventually be partially obscured. But for those, as I've mentioned, who are lucky enough to be in the right place, right time, they will have a stunning view, which will be this ring of fire effect, which I keep talking about. It will be stunning. This is just another graph, really, just to make it a bit clearer with a bit of color and a bit of depth to it, just to demonstrate the various times as when this will be taking place. So as you can see, really the path of the partial eclipse will definitely be taking place between 10 o'clock in the morning and will be visible to around midday. Although I do have other times on this which will be important for us. But from the United Kingdom, we will be able to observe 21% coverage. So it's not going to be as much as, say, some of our viewers in Canada and Greenland, for example, but still, it's a celestial event. It's a great way for us all to be connected through the night sky. So definitely make sure that you've got your eclipse glasses and so on. So it's definitely worth taking a look. If you guys are interested, I do have some eclipse glasses just on my cupboard over there, and I'm more than happy to show you them at the end if you so wish. So we're now going to talk about lunar eclipses. I love these events as well. They are really the opposite of a solar eclipse. The reason why is because the alignment between, in this instance, the sun, the moon, and the earth is reversed. So this means that the alignment takes place between the sun, the earth, and the moon. So when this alignment happens, we see a dramatic change in the surface of the lunar disk. So let me explain that to you now. This is an image that I captured again in the same year between, it was on the evenings of September 27th through to September the 28th, 2015, and was the first total lunar eclipse that I had observed. And as you guys can see in the images, it was a very fortunate event, purely because the skies were clear and the fact that a total lunar eclipse was taking place, which allowed me at a very young age to be able to document this through the eyepiece of a telescope. So for the period of the eclipse, I just had my telescope set up all night, had cameras fully charged, and literally taking images for the period of 6 hours for which this eclipse lasted. So just to describe to you exactly what's going on here, this is an interaction really of the Earth's shadow. So as I've described already in the alignment taking place, it's between the sun, the Earth, and the moon. And what happens here is light from the sun passes towards the Earth and projects its shadow onto the moon. This is the composite which we can see happening here. What's important to mention, and I'll just break this down because it took me a little while to get my head around it as well, but there's two different types of lunar shadow. So we have what is called the penumbra, but we also have what's called as the umbra. I'll try and demonstrate this through a series of images, but I will also demonstrate this on my image just for a bit of clarity. But the penumbral shadow is this slightly weaker edge that we see commonly with lunar eclipses. It's a less intense shadow. It's just that moment when the intensity of the lunar shadow is actually occurring on the surface of the moon. But it's this intensely dark shadow, which is called the umbra. So the way I always like to try and remember it is that the penumbra is the weaker shadow, but the umbra is the much stronger shadow. And what happens as this event occurs and as it gradually works through, we begin to see this very unusual event where the color of the moon begins to change. And all of this is to do with refracted sunlight. especially towards the red wavelength of the spectrum through the Earth's atmosphere. And this basically turns the moon a coppery red. So hence we hear the term blood moon being used. So already it's, dramatic to see. And I think the best way of describing of what one of these lunar eclipses looks like is one of these two images, because they really are, that is the true sort of clarity I remember seeing with this lunar eclipse. You see that view in the night sky. Now, it's really upsetting from an astronomical point of view, because in fact we had one of these only yesterday, but the only problem being is that these events are all geographically dependent, which means for the total lunar eclipse which occurred yesterday, it favored mainly those living around the Pacific, which meant eastern fringes of Australia and also the very western edges of the United States, and that in the middle were able to observe this particular lunar eclipse. Otherwise, I would have loved to have shown it to you guys. However, it was not visible from the UK. So we've had loads of images streaming through online recently of this eclipse, and it has really and truly been stunning to see the images flood in. So gradually, the same thing happens again. So the moon is totally eclipsed by this point, and eventually the Earth's shadow begins to retreat. And so really that is the dynamic of a total lunar eclipse. This image presents it quite well as well, just looking through, and it's interesting to see the changes of color in different lunar eclipses from one eclipse through to the next. As you can see here, just because of the interaction of light through the Earth's atmosphere, they appear much more colder in color, whereas some lunar eclipses, they appear more red. And it's just interesting to measure these fluctuations of what is happening through the Earth's atmosphere when one of these lunar eclipses takes place. But they are incredibly dramatic. I can just remember observing the eclipse of 2015, on a moonlit night of a full moon, you would be able to see, shadows being cast by the intense brightness of the full moon. And then suddenly you would see the moon being eclipsed. It would just gradually grow across over a period of 1 or 2 hours until eventually that light was being blocked and it was suddenly dark. You began to see details again in the Milky Way galaxy. You would see more stars. So really, it is quite an eerie sense when you see like a red-colored moon, which is something we're not used to, but it does make an amazing sight to behold. So when we next have a proper one of these events visible from the UK, I'd love to show it to you guys because they are stunning. What I'll also mention as well, because we're talking a lot about interaction of celestial objects, is transits. Now, transits are very, very similar to eclipses, but there's a slight difference here where it involves, first of all, a different object compared to the moon, which in this case involves typically an innermost planet in the solar system. And transits of this stature, as observed from Earth, are usually occurred between the planets Mercury and Venus. But it's also important to note that from other bodies within the solar system, it's possible to observe different kinds of transits, such as certain oblong-shaped moons of other worlds, whether that be on the planets Jupiter, Saturn, and Mars in this instance. But transits, as seen from here on Earth, typically indicate towards the innermost planets. So let me try and demonstrate what I'm talking about. I was very unfortunate not being able to observe this event. This was a fantastic event, which is known as the transit of Venus. So I'm hoping this image describes enough to you. It looks really abstract, I know, but this image is basically the solar disk. This is the sun. This black spot, which we happen to see here, is the silhouette of a planet. This is the planet Venus, and this is when, quite literally, the planet Venus will transit in front of the solar disk and can be documented for a significant period of time. Now, I wasn't able to observe the last transit, which now means it will not be possible to observe another transit for at least 100 years due to the dynamics and the orbits of our objects in the solar system. So unfortunately, guys, I don't even think I'll be observing a transit of Venus anytime soon. So it's just good to talk about and just to understand what celestial events are possible, but just for the purposes of conversation, we may not see one of these anytime soon. What has been more recent, and I'm sure there's some members here present in the audience who will remember one, but there was back in 2016 a transit of Mercury. Now, I met a number of my now astronomy friends there when I observed a transit of Mercury, but again, they are really stunning to watch as well. The thing which makes transits of Mercury a bit more challenging is the apparent size of the solar disk to the planet itself. There is a significant difference between both the Sun and Mercury in this instance, in sense of apparent size as well. So it appears very small on the solar disk. But gradually, as you take images, as I showed you in that image previously, this one, for example, shows it, you can see the planet quite literally transit along the solar disk. So astrophotography really presents it in a very clear to see fashion. So yes, this image really captures it well. And I think it's quite amazing really, because this image, I'm looking at it now and you think, wow, look at the sense of scale between both celestial objects. So you're seeing the size of the planet Mercury. We haven't even covered 1/4 of the solar disk in this image. So really, this gives us a sense of perspective as to how large the sun is as captured from this perspective. It is humongous. You can even see granulation, which is the surface feature, which I was trying to describe earlier. So, you know, quite a lot of interesting things which are going on here, which is really nice to see. This was a recent image, you know, taken from various wavelengths of light, which shows the planet Mercury before it begins to transit the solar disk. So this is really interesting to see from a different perspective, where you can actually see the solar corona, as I previously discussed in the topic of total solar eclipses, as it begins its approach to cross the sun. So I just thought, you know, this image really struck me really, not just because of the colors in which this image was captured through in terms of wave bands, but just, you know, how astronomers are able to document these events, which was the case certainly for this picture. Now, just before I go over towards any Q&A, I just wanted to highlight on two particular books. I'm fortunate to own both of these copies, but I tell you, if you are passionate to learn about any type of eclipse, I recommend the work of a fellow astronomer called Fred Espinac. He is an official, you know, eclipse specialist for NASA and has been responsible for producing these books. 1,000-year canon of solar eclipses and a 1,000-year canon of lunar eclipses. So based on scientific data, you know, he's been able to calculate basically all the solar and lunar eclipses for the next 1,000 years or so. So it's quite good to have. And these books are fantastic. They use plenty of diagrams, plenty of graphics, images, and you can really begin to plan out where these eclipses are taking place. Like in the images which I showed you previously of the graphs of the eclipse path happening over the Earth, there's loads of them. And, you know, I've used this book multiple times to learn about the dynamics of eclipses. But again, we can see where eclipses will be favored, whether that be in Australia one time, in, say, Iceland, Greenland, Canada, like what's going to happen on June the 10th, for example. So these are worthy books to get. You can order them on Amazon, you can order them online. I'd love to see you guys with a copy of them. They are beautiful books, so I totally recommend them if you like to study these eclipses much further. Now, in terms of resources, I like to refer to this resource online, which is Time and Date. It's really good because it's an interactive digital platform where you can search literally for eclipses which will be visible from your local area. So for example, if you just happen to live in some local examples, Midsummer Norton, if you live in Wales, if you live in the Chew Valley, you can type your location into the search bar. And what this does is calculate what eclipses will be visible from your region on a given day. And also what's really interesting, and they have added recently, is a cloud coverage likelihood, which tells you what the weather might be like on the day. So if you need to travel around the country a little bit to boost your chances of seeing the event, then you can, and you can plan this in relation to maps as well. It's a really good resource to have. And as I showed you in the diagrams earlier, it shows you the intensity of the eclipse based on color and the places which are more likely to see the event. So really worth having a look at. You've got some interactive 2D, 3D maps to look on there in your free time. So I really recommend those as another secondary resource. So I believe that covers most of the content so far for our Celestial Events workshop. I include this always at the end of my workshops purely because if any of you guys are interested or are currently looking into some of the subjects which we have previously discussed in our virtual astronomy workshops, these videos will be hopefully available indefinitely in the near future on how to continue observing objects in the night sky. So if you guys are lucky enough to get a period of clear sky, then I totally recommend trying to watch some of these videos so that when you get your clear sky and you're thinking, how do I observe Ursa Major, Ursa Minor? How do you find Orion? If you want to look for galaxies or black holes, then you can. You've always got it there as a resource, day, night, 24/7. So they're there for you to watch. And so you can check those out at our YouTube channel at Space4All UK and at Josh Jory Photo Media for your interest. Just before I go on to the sort of ending conclusions of this slide, I just wanted to say also again, guys, thank you for being very patient with tonight's workshop, because when I was sending out all the promo for this event tonight, unfortunately, I did have a few glitches on Facebook, which meant the event wasn't advertised 1 week in advance as it should have normally been. However, that's the reason why the event was taken up last minute. So I just wanted to appreciate for all of your guys' attendance. Thank you for being there in such short notice. So I just wanted to say that before I forget to. If you guys are new members as well, please make sure to check out our social media channels on Facebook, Twitter, YouTube, and Instagram, because this is how it's going to work, guys. If we want Space4All to work, we want to get more people interested, we need to just spread the word. That's the way this is going to work. Anybody who you know has the most basic interest in astronomy, mention it to a friend. Oh yeah, Space4All, come and join our local astronomy society. We're connecting with other local astronomy groups, for example, Somerset Level Stargazers, who I did a talk for previously last night, a lovely group of astronomers and lovely to connect with them as well. And that is the initiative of Space4All, is to connect with like-minded people, because space literally is for all of us. So in terms of moving through our astronomical calendar, this is the series of events which have played out throughout 2021. So just for those of you who are new, in January, we covered the constellations, February, the planets, March, the moon, April, deep sky objects, and we are now in May, where we've observed celestial events. But as we move into June, we will now focus on the sun. So what I will also mention here, guys, because this month is a particularly important month because of June the 21st, because not only is it summer solstice, but also in relation to UK government guidelines, this could potentially be the opportunity where virtual astronomy workshops may well cease and public events will then be permitted. So as you guys understand, Space4All is a very newly developing astronomical organization. So as soon as the opportunity permits, I would literally like to get a public event sorted as soon as possible. And it would be lovely to see all of your guys' faces after this long as well, which would be really lovely. And, you know, just flicking through those who are currently present on my in my attendance list here, I also appreciate the fact that there are members who are not very nearby to Somerset. So I just want to mention this as a very early plan, just to make you aware that a virtual presence will always be present in my workshops, so that whether we are in a public audience, there will always be a digital presence online in the form of a Zoom meeting similar to this. However, it's a newly developing area. It's a way for us to connect in a way which we have never done so before. So it gives us loads of potential to expand. So these are just some of the options. So what I'm trying to say basically is any time from June onwards could be a potential where this could take the form of a public event, whether that be safely observing the sun, to actually having a go at a bit of astrophotography and observing the Milky Way. So I'm hoping that in August, we'll begin to cover more about meteor showers. So I'll tie this in with meteor showers and the Milky Way in this instance, just so that you guys are aware. And in this instance, I have usually been doing virtual astronomy workshops on Thursdays. However, if government guidance permits, I'll try and change this towards a Friday or a Saturday. So we'll wait and see how it works out. We still got lots to learn as an astronomy organization, so it will all be kept under loop, and I will feed that back to you as soon as possible. So I just hope that gives you a bit of a feeder in what we hope to anticipate for the remainder of the 2021 calendar, as weird as this year and last year have already been, but I don't need to say any more about that. So we now go on to our typical Q&A session. So I will stop the screen share there, go back into Zoom and see if anybody has asked any questions. Otherwise, this gives an opportunity for anybody to unmute themselves if they would like to ask any questions about tonight's events. So just to check if anybody had any questions, did that all make sense? Was that explained clear? Ah, yes, Phil. Hello.
Hi, Josh. Hi. Thanks for a really interesting talk yet again. You were going to show us some solar glasses you've got.
Right. Okie dokie. They're just on my cupboard. So bear with me 2 seconds. I will just go and grab them. So give me 2 seconds. All sorting through my items. I literally ordered them online the other day. So let me have a look and try and get everybody on screen so I can see what I'm doing here. Fantastic. Solar eclipse glasses. If I try and show that up against my black cover, these are eclipse glasses, everybody. You can order them online now. They are beautiful things. And, you know, they come with, you know, terms and conditions on them. They are safe to use. And I recommend using these when observing any kind of solar eclipse. They're very cheap. These were about £1 each. And, you know, I'm just a typical astronomy nerd, so I thought I'd get mine early in advance. But they're available now if you like to get them.
Great, thanks. And I mean, are there any precautions? Because I guess you can get some really cheap ones that maybe don't work and you could risk your eyesight with those, couldn't you?
So what I always like to look out for is particular British standards when looking out for solar eclipse glasses. In this instance, these, which I currently have here. Always try and look for certified solar eclipse filters and viewing glasses, because as Phil correctly mentioned, you can get a black market for these kinds of equipment. So always make sure to double check that they have been certified to German standards. This is another thing I like to look for. A bit technical, I know, but it just gives you some confidence and guarantee that what you are buying is safe to observe. And also, now you've mentioned it, Phil, I've gone off on another tangent. If you are interested, you can also buy solar material or solar filter material known as Badar solar paper. It's really useful. It looks like tin foil, but you can literally cut this material down to size, and you can use that as a solar filter. It blocks 99.99% of light, and I've used it for all of my eclipses as of yet, and is about £20 for an A4 sheet. So it's all thoroughly safe to look through, and I can reassure you on that.
And would you use that that material as a filter on a camera if you wanted to photograph it?
Yes. Oh, yes. If you've got any lenses, all you need to do is literally measure the diameter. So in this instance, I will use my astronomy mug. But if you pretend this is your lens, you measure the diameter of your lens and you mark this out on the solar sheet and you cut it appropriately to size, and it tells you how to make your own solar filter and everything. It's really cool. Bit of DIY, and it's also safe to do. So it's all guaranteed as well. So yeah, hopefully that helps.
Cool. Thank you.
All right, Phil, not a problem. So did you guys, did that all make sense for you? Was there anything which seemed a little bit mind-boggling, or was that all okay for you guys?
Okay.
Yeah, all good, Jack? Yeah, did that all
Yeah.
make sense for you? Yeah.
I'll tell you something that does boggle my mind about this is how the moon does a perfect eclipse of the sun.
Yeah.
You know, when it's a total eclipse, it's like a perfect, isn't it? How the chances of that actually happening, getting the distances, the size of the moon, and everything right, it just seems to me to be an infinitesimally small coincidence that it could be the perfect size of the disk.
Yeah, it's really fortunate in so many ways, Phil, because there's other details which I purposefully haven't mentioned tonight, but it's all to do with Earth's tilt at the time of the eclipse, the gradual, tilt between both planets. So it's all really to do with chance, because if the alignments were absolutely dead perfect all the time, and in a hypothetical universe, we would get an eclipse happen every single month. But because of the nature of these eclipses and the orbits and all the other elements which are involved, these occur over very irregular points, which is what we're seeing now. So what is typically appropriate with eclipses is that when we see a lunar eclipse, like what happened yesterday, a solar eclipse usually happens about 2 weeks later, which is the case for June 10th. So in terms of dynamics of eclipses, yeah, they are some very interesting events to behold, that's for sure. But otherwise, guys, were you all happy? Just to give a thumbs up, that all made sense for you guys? Yeah. Oh, fantastic. I've done my job properly. Brilliant. Okay, guys. Well, look, listen, we're nearing towards 8 o'clock. Phil's got a good idea. He's got a beer in his hand. I need a drink now as well. So I just want to say, as always, thank you so much for joining me in tonight's virtual astronomy workshop for Space4All. And, I'd like to wish you all happy stargazing. Happy summer solstice when the time comes around. I hope to see as many of you at our next virtual astronomy workshop, and thank you very much for joining. So I will now end the call, and it's lovely to see all of you. So clear skies and all the best.
Thank you, Josh.
Thanks, John.